we're going to start Unit 3, everybody, with relations and functions. So we are going to have some terminology, and we are going to do a lot of describing of relations and functions. So let's start with our first definition. So you're going to want to keep note and keep track of all of these definitions. The first one is domain of a relation. What is a domain of a relation? Well, the domain of a relation is the set of all of the x coordinates from the ordered pairs in that relation. Domain, you also want to think of as the input. That takes us to our second definition, and that's range. What's the range of a relation? Well, the range is going to be the y values. So it's the set of all the y values from that ordered pair in that given relation. And I also like to think about range as the output of that given relation. Now let's talk about the various ways that we can represent relations. They could be represented by ordered pairs. We could represent relations using a table of values. We can represent relations by mapping, which illustrates how each element in the domain is paired with an element in the range. We could represent relations using graphs. And lastly, we could represent them using equations. We'll talk about each one of these representations in a little more detail coming up. But before we do, let's talk about a special kind of relation, a function. A function is a special kind of relation where each element that's in the domain is paired with exactly one element in the range. That means for every input, there is only one output. So we have a test where we can determine whether or not a relation is a function. And that test is called the vertical line test. Let's do an example of the domain and range and whether or not it's a function, starting with the ordered pairs. So you'll remember that for ordered pairs, the domain is the x value. That's the input. And our ordered pairs follow that form of x comma y. The domain would be the x value. So in this example, the domain would be -1, 0, and 2, because those are the x values. Our range is the output. Those are the y values. So in this example, our range is 2, 5, and 7. Whether or not this is a function, we want to identify if every x value only goes to one y. And here, -1 only goes to 2, 0 only goes to 5, and 2 only goes to 7. So yes, that is a function. Now let's look at the example for the table. You'll see the x values in this are the first column and the y's are the second. We could always write these as ordered pairs as well, but no need. So let's write out what our domain is. Those are the x's, so the domain is 3, -2, and 0. And you notice we didn't have to put 3 again because we already identified that it's in the domain. The range is now going to be the y values. So we can see that the range is 1, -4, 2, and 6. Now, is this relation a function? Here is the one thing we want to identify. We saw that 3 maps to 1 and 3 maps to 6. That one input goes to 2 different outputs. So no, that relation is not. So with our mapping examples, here we have our x values going to the second circle, which is the y values or ovals. So I think this should make sense now. What would we say the domain is? That's right, -7, 0, and 3. And our range is 1 and 2. Is this relation a function? And folks, the one thing we want to identify, do all of my x values go to one and only one y value? -7 only goes to 2. 0 only goes to 2. 3 only goes to 1. So since all of our inputs go to only one output, it's a function. It doesn't matter that both the -7 and the 0 are going to 2 because they are only going to that one value. So I enlarged this a little bit for the graph so we could see more clearly. One thing that we want to be keeping in mind is that the horizontal values are the x values. Those are our domain values. The y's, that's the vertical, and those would represent the range. So when we're looking for domain and range for graphs, we want to look at first, let's look at domain. We want to see what x values are included on this graph. And you can see that it looks like all of the x values from here to here make up our graph, right? All of those x values in between -3 and 1. So we're going to use what we call a compound inequality to write that. So for domain, we would say that all of the x values in between -3 and 1, including -3 and 1, are the domain. And we could also express that as -3 is less than or equal to x, which is less than or equal to 1. Similarly, we're going to look at the y values now for the range. And we can see here that this is the lowest y value that's included, and this is the highest, because all of those y values are part of our graph. So how would we express that? We'll use another compound inequality. And that would read that -2 is less than or equal to y, which is less than or equal to 3. That means the values, all the values in between -2 and 3 are part of our. Now let's talk about that vertical line. So if they're asking me, is that relation a function? What I want to do is I want to think about if I had a vertical line and I dragged it across my graph, would it intersect my graph in more than one point at any time? If it cuts through at more than one point, even once, it fails the vertical line test. And I think we can see that this vertical line would intersect that graph in 2 places. And if that happens even once, it is not a function. So our answer for this is no. And just so that you know, we are going to table the domain and range questions for equations, and we will circle back to those.